Howdy! So today we're going to review solving equations using graphs. And this is like probably the easiest method we could use because you just get to use a calculator. But it's important that you understand what we're trying to find so that when you read the problem, you can remember how to use this skill. So if you recall, a system of equations, oh, my pen's going to be slow. Oh no! Okay, my computer just froze on me. Okay, a system of equations is a set of two or more equations in the same variables. So for example, here is a system, meaning that it's like more than one equation, a system, and we only have x's and y's in this system. So this is a system. A solution to that system is when there's an ordered pair, so say like an x and a y, right? An ordered pair is an x value and a y value, that works with both equations. So a solution has to be true for both. So the solution to a system of equations is when the two equations are equal to each other. We want both equations to be equal to each other. That's a solution, meaning it'll work in both. We found the solution, it works for both. So to find that point where x and y make both equations true, we're going to graph the equations and find the point where they intersect. Or in other words, touch. So that intersection point, so the point where they touch, are the x and y values, are the solution for the equation. So look at this example here. They went ahead and graphed the two equations from the example. We have x plus y equals 7. That's that blue graph. And then they have the 2x minus 3y equals negative 11. And they would maybe ask, what is the solution? That's what the question would ask. What is the solution? So with that, you would graph both of these equations and notice here's this point where they touch and where it's the same exact point. That point is at 2, 5. That's the x and y point. So that's our solution. The solution would be 2, 5. So here's how we would graph this on our calculators. I've recommended, just because of online and all the funkiness, to use Desmos.com. So say that we have another example. Let's say we have number 1, and we want to find the solution. So I'm going to take these two equations that they gave me, and I'm going to graph them. So on your calculator or on your computer, I'm going to kind of do it on the side. We're going to go to Desmos.com, which most of y'all already know that by now. We can go to the graphing calculator. So on the calculator, I'm just going to type in these two equations just like I see them. Y equals negative 3x plus 4. And then my second equation is y equals 3x minus 2. So once I graph these two equations, I can maybe zoom out or zoom in if you don't see a part where they touch. But here is where those two graphs touch. So I'm going to click on the point where they touch, and I see that my answer is 1, 1. So 1, 1 is my solution. And that's it. Hopefully that's pretty straightforward and that you remember how to do that on Desmos. So I want to do another example of maybe a word problem that you're also going to see on this exit ticket. So say that you have an Astros game, costs $25 plus $3.50 for every hot dog. So I want you to think about a line here, right? For an Astros game, we're going to pay $25 regardless, plus $3.50 for every hot dog that I buy. So however many hot dogs, I'm going to call X my hot dogs. For every hot dog that I buy, I'm going to multiply that by $3.50. Then we have a ticket to the Texans game, and that costs $20. So we're only going to pay it one time, so I'm only going to write $20 one time with no X next to it. But at the Texans game, each hot dog is $6, so 6X. So here is my two equations. I have one for the Astros game and one for the Texans game. I want to remind you that when you think of the words each or per, all of these are talking about like slope, or you want to multiply by X. So you want to multiply by X. If it's a one-time cost, or like the starting position, something where you start at, that's going to be like your y-intercept, where you just keep like the plain number. So again, we only pay that $25 to get into the game one time. So I don't want to multiply that by X because I'm not trying to pay $25 every time I buy a hot dog. I'm only going to pay $3.50 for every time I have a hot dog. So the question is asking, After how many hot dogs will the price at each game be the same? Keyword is the same. We want to graph both of these and see where are they the same? Where are these two equations the same? So watch how I'm going to go to Desmos and just plug in both of these equations. Now, I don't have A and T, so I'm just going to use Y instead and just call it the total cost. So I have Y equals 25 plus 350X, that's 1. Then I have the Texans game, which is Y equals 20 plus 6X. So I can't see any lines, I just see this one that's kind of in the way. But if you zoom out, there my two lines are, and there's where they touch. So I see that I have this intersection point, 232. That's when those two things are the same. But we need to make sure we understand what that means because sometimes they're going to ask us a question about it. So we'll just say that already the solution is 232. But what does that mean? Well, you remember that an ordered pair is like an X and a Y. Ordered pair is an X and a Y. Well, we said that X was the hot dogs. So what this means is that after 2 hot dogs, the price of both is the same. So the price is the same. And what is that price? Well, this equation was for the total price, and that's that Y value, which is $32. So make sure you answer, and it says, what is the price? That would be the Y value. So make sure you understand what your X's and Y's are so that you can answer the question correctly. Okay, the last thing I want to go over really quick are just some special cases, and so some weird things that you might see. Look at this graph. They graphed 2 lines, but notice that I only see 1 line on this graph. There's only 1 line. So when graphing a system of equations, if the graphs are always intersecting, meaning that there's no like cross, they're like on top of each other, so you can also write this as like on top of each other, that means that they are the same line, therefore there are infinite solutions, meaning there are so many places where they're touching. Like they are working at this ordered pair, and at this one, and at this one, and at this one, and at this one. Oh, and the little one next to it, right? Like all of those are possible solutions. So this means infinite solutions, and think because they're always touching. Sometimes you might see 2 lines that look like this. There's like 2 lines, they're straight, and they kind of look like railroad tracks. Notice that even if you zoom out and zoom in, they're never going to touch. Never touching, ever. So if the graphs never intersect, meaning they never touch, then there is no solution because there's no spot where they're the same. They're never going to be the same anywhere. So make sure that you understand that these are also special things that can happen when you are graphing and finding the solution. Okay, I hope that was helpful. Now go ace your exit ticket.